governance throughout the ecosystem. So, for example, our DYDX validator are voting for proposals every week, but we are we are also building the technology for decentralized governance. So today I'll be talking about the most recent development, which is the general anonymous Meisei interface on Dora Vota. So just a quick survey. So does everyone know about Meisei and how that works? Okay, probably I will just do a very quick rundown about Meisei. So Meisei is a very simple but powerful anti-collusion infrastructure, which is super useful in decentralized governance and voting. So as a voter, so imagine that you are in a governance round, you sign up and you encrypt your vote and you cast your vote on chain. And then on the other side, there is the operator who bring down all the messages and decrypt the messages and generate zero knowledge proof and finally validate it back on chain. So Meisei has already been implemented on Cosmoverse, therefore it's already available on the Interchain stack. So we did that early next year. And after that, we started to another product called Dora Vota Meisei. So it's a general and portable Meisei interface for anyone who is interested in creating a Meisei voting round for any ecosystem. So on the left hand, we have this Explorer where you can see all the details of the Meisei round. And as an operator, so if you're running your own Meisei round, you can create and manage your Meisei rounds from this simple UI. And together with that, we also have the portable Meisei, which is the open source voter front end. So it's pretty important to expand the open source front end ecosystem for Meisei. So imagine that you are running a Meisei round. What you can do is either you can create your own front end, or you can just use this open source front end, or you can build your own front end from this open source version. And the final thing we provided was a set of scripts for Meisei operator. So if you are operating a Meisei round, this set of script is going to compress everything that the operator is going to do, ever from preparing for the Z key, downloading the messages, telling the round, generating the zero knowledge proofs, and validating that on chain. So everything will be compressed into one command, making the operator's life much easier. So we actually released the product last year at the Cosmoverse conference. And ever since then, there was a wide adoption of Meisei across the Cosmos ecosystem. So in the first place, there were some smaller rounds, like hackathons. They were using Meisei for project judging. They invite judges to vote for their favorite projects in Meisei. And earlier this year, in the summer, we had this AEZ quadratic grant following the approval of governance proposal 917 when we started to kick off the quadratic funding grants on DoraHacks. So what happened was that in the round, there were more than 1 million Atom staker addresses got whitelisted. And there was a great turnout from the round. And there were more than 10,000 Meisei messages casted on chain. So there were thousands of people from the Cosmos who participated in this Meisei round. What it enabled was the largest ever Meisei voting round in the Web3 history, and it allowed that every Atom staker to directly vote for public goods in the ecosystem. So it's sort of a revival of direct democracy on chain. And then later we got several other rounds, including the Celestia hackathon round, which is also inviting the community to pick up their favorite hackathon projects. So next, we'll be talking about the Macy trust assumptions. So as a general framework, Macy obviously has some trust assumptions. It relies on the honesty of the operator. So the operator can obviously collude. And if the operator does that, the whole round will just collapse. So how do we solve that problem? Is through an upgrade on the protocol. It's called anonymous Macy. So the idea of anonymous Macy is actually quite simple. You allow an additional operation for the user, which is the users now can deactivate their key. So when they vote for anything in the round, they will have a key and they can deactivate their key and then register for a new key. So when they do that, they will do that secretly. So with the help of zero-knowledge proof, when the voting key is deactivated and re-registered, the operator cannot figure out which key actually corresponds to which user, and then the operator will be totally confused. So there are some challenges during the implementation of anonymous Macy. Some involve cryptography, some involves engineering. So I'm going to skip this part. If you're interested in the detail, I had another talk back to June in New York at the DevMos, where I give a lot of details on how we actually implemented anonymous Macy. Right, so we did the research, and the first meaningful adoption of anonymous Macy was earlier this year at East Vietnam, where at a hackathon we deployed an anonymous Macy round, and then there were more than 100 hackers participated in this round, and they gave us very valuable feedback on the product. So after that, we started to build into Dora Vota, because by doing that, we will be able to facilitate Macy rounds throughout the Interchain community. And actually, just a week ago, we released the anonymous Macy interface on Dora Vota. And currently, if you go to Dora Vota's website, you will have the option to deploy an anonymous Macy round compared with a classic Macy round. So the most fundamental upgrade here is that we are enabling third-party operators. So in a traditional Macy round, it has to, so whoever initiates the Macy round has to be the operator, him or herself. But in anonymous Macy, because of the reduction of the trust assumptions, now you can hire third-party operators and hire them to do the job for you. So so from the UI, if you are starting a Macy round, now you don't have to configure your operator keys and all those stuff. You can just select one of the operators from the drop-down menu and pick up your favorite one and let the operator do the work for you. So currently, every operator is a Dora Vota mainnet validator. So asking of the mainnet validators to function as a Macy operator as well. So the next step is to fulfill the mission of a Macy, which is to create permissionless operators, which means everyone could become an Macy operator and tally the votes for other people. So the purpose of a Macy token economics is to facilitate that. Right? So I did a very rough write-up in September, and for those of you who are interested in how that works specifically, you can go to Dora Research website and refer to the article. But there are two basic ideas behind the AMASA token economics. So the first idea is that we want to encourage and incentivize good operators to perform well and keep performing well. So good operators, that tallying the votes correctly and on time, they have to be rewarded. And the second idea is that we want to make sure that the AMASA round actually scale. So think about some very important voting rounds like national election or some super critical, super high stake voting rounds in Web3 community or Web3 ecosystems. You definitely want to make sure that the AMASA operator is doing the right job, right? So in terms of tallying the votes, so the operator has to do that correctly and timely. So the solution to that is we are going to introduce an economic guarantee in the form of an insurance fund, so that every AMASA round can be insured based on the importance of the round. So with the token economics and all these infrastructures, we will be able to achieve permissionless operators, which is a major milestone in MASA and a major milestone in decentralized governance. Right. We also have a few other product features that we just brought to Dora Vota. So first of all, if you are tallying a round, whenever the round is successfully tallied, you will see the leaderboard on the round details page, and there is a gas station feature for the round owners. If you want to make sure that the voters are free to vote, you can set up the gas station, and you can pay for the user's gas fee. And the search function is user experience is improved. And finally, we have integration into DoraHacks. So it's called Hackathon AMASA judging. If you're organizing a hackathon on DoraHacks, now what you can do is, in addition to the traditional judging features, you can start an AMASA judging round on DoraHacks. And then you can invite your community members to vote for their favorite projects from the hackathon. Okay, so we actually just released the product a week ago. So all of the AMASA infrastructures are currently under very intensive stress, and that will last for a few weeks, and then we'll step into the token economics. So hopefully by the end of the year, we'll have permissionless operator for anonymous MASA. But nevertheless, you can still start an AMASA round at vota.dorafactory.org, or just try it out. And also put up the QR code to our recruiting, just in case you need it. Thank you very much.